Welcome back. Let's do question 10.2. A 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 and 1. Digits may not be repeated. Right? We managed to find the possible 4-digit combinations in question 10.2.1. Now, it says, calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5000 and the third digit is 2. Right, so we have different situations here. Since the code has to be an even number, it can end with a 4, it can end with a 6, it can end with an 8. But remember, 2 is also even, but we're told that 2 is fixed as a third digit there. So it's a restriction there. Let's say our situation 1, let's say ending with 4. We have our 4 slots, 1, 2, 3, 4. The third digit is for 2, so we have 1, 2 here, so we have one choice. All right, and then the last digit, if it is 4, then it is fixed. We have 4 there, we have only one 4, so it's 1. And then 2 numbers are taken. We're left with how many numbers? But remember, this number can only start with a 5, a 6, a 7, 8, or a 9. And so it means we have 5 choices for the first number there. That is 5 choices. And then we have how many numbers taken? We have 3. 1, 2, 3. So we're left with how many numbers to choose from? From 8, we're left with 5. So it means the second slot, we still have 5 choices. That's when it's ending with 4. Let's say ending with 6. Ending with 6. It means 6 is going to be fixed. 1, 2, 3, 4. So it means the last position will be for 6, which is 1, because we have only one 6, so it's one choice there. Then this third position is for the 2. We're told that third digit is 2, so it's fixed there. We have only one choice there because there's only one 2. So this one is taken, this one is taken. We're left with 6 numbers, but our number can only start with a 5, but the 6 is already taken, so we cannot count it. So we have 5, 7, 8, 9. So it means we have 4 choices for the first number. So 3 numbers have been taken. So we're left with how many numbers to choose from? We have 5 choices for the second slot. And then let's have the third situation. The third situation ending with 8. Right, when ending with 8, 1, 2, 3, 4, 8 fixed, and then 2 is already fixed here. So we have only one 8, so there's 1 here. Only one 2, so we have one choice there. Right, so 8 is taken, and then 2 is taken. We're left with how many numbers? 1, 2, 3, 4, 5, 6. But our number can only start with a 5, 6, 7, 9. 8 is already taken, so we cannot count it. So we're left with 1, 2, 3, 4. 4 choices. So now we have 3 numbers taken now. For the first slot, third slot, and last slot. So out of 8, we're left with 5. So it means for the second slot, we have 5 choices. So now we have this combination here ending with 4. So it means how many different combinations you can have? 5 times 5 times 1 times 1, which is equal to 25. And then here we have 4 times 5 times 1 times 1, which is 20. And then here we have 4 times 5 times 1 times 1, which is equal to 20. So it is this situation or this situation or this situation. And remember, when it's all, we add. So now it means the total number of combinations that meet these conditions. The total number of combinations that meet these conditions is going to be 25 plus 20 plus 20, which is equal to 65. But remember, we're required to calculate probability. And probability is the number of the combinations meeting the conditions, which is 65, divided by the total number of possible outcomes, which is 840, which is 13 over 168. which is equal to 0,0773. It goes on like that. Then to 2 decimal places, this is 0,08.